Wednesday, the 9th, the second half or part 2 of the homework quiz was due. So if you didn't get it done, you can still do it for partial credit, so I would take a shot at it still. On Sunday is when your exam's due. So for the exam, it's just on Chapter 1 material, so the stuff we've covered so far, the stuff on this review sheet, the stuff in the quizzes. Okay, the quizzes and the review sheet are really going to help you study. It's 35 questions long. I think all but one question is multiple choice. So I think there's one fill in the blank. But otherwise multiple choice. You have an hour and a half is the time limit. So when you're ready to take the exam, I recommend you have your calculator out and ready, you have any conversion sheets or equations that you need ready, and you have a quiet space with good internet connection. Okay, so you do have just one attempt to take it. And how it works is you'll get one question at a time. So it's not going to show you the whole screen of questions, but you can backtrack. So like if you answered a question and then you rethink it later, you can go back to that question. You're just going to have to click a couple times to do it. So that is due Sunday by midnight, like I said. It's going to open tomorrow though. So if you're ready to take it, you can take it tomorrow. If you want to take it, get it out of the way, enjoy your weekend, or if you work on the weekend, it will be open. I think I have it set for 5 a.m. I don't expect anyone to take it at that time, but I just wanted it available the whole day for early risers and late evening owls. So the other thing that's due by Sunday is your discussion. Discussions are always due on Sunday, so I didn't want to just change that because there was an exam. And you can always do it beforehand. I recommend you do it before you take the exam, but that is your choice. So with that out of the way, we're going to start doing the review. And you'll notice the Exam 1 review, and this is on Blackboard, so it's going to be posted right above this video, so people watching virtually just follow along on this, because I'm not going to write down word for word what's on here, since there's already a copy on Blackboard. So I'm skipping the definition section, because I want you to look up those definitions on your own. Writing them down helps you remember them, keeps them sticking in your brain a little bit better. And there's only a few of them. So most of them are, actually I think all of them are from the scientific method page, or the scientific method PowerPoint. So I have a folder of just the PowerPoints without my voice talking in them. So if you want to use that to just look up the definitions, you can go slide by slide and stop on the slides that have the definitions instead of watching the video and trying to pause it. Those are available to you as well. So look up those, write them down. You might want this handy when you take the exam. I mean, it's open note, open internet, open book. So doing a good job at filling out your review will probably help you quite a bit. All right, so I'm going to skip now down to recognizing the steps of the scientific method and being able to apply them to situations. So that's what we're going to start with. There's 4 different scenarios here. So with the scientific method, it's an organized approach to solving scientific problems. So it's that method that starts with an observation, then it goes and asks the question. From the question, you come up with a hypothesis, which is your educated guess to why you think what is occurring is occurring. From there, you do experiments and data collection to try to make your hypothesis into a theory. So have that flow chart in your mind, and we're going to apply those steps and figure out with each of these situations, with each of these scenarios, what step we're talking about. Okay, so the first one is wondering what type of fertilizer works best. So when you're trying to figure out what step of the scientific method is being described here, look for keywords. So what I'm going to write here is the keywords that I see that helps me figure it out. Okay, so for the first one, the word wondering is what's going to tell me what step. Okay, so looking at the scientific method, the first step's observation. Okay, observation is your senses. Taste, touch, smell. Okay, so is wondering a sense?
No.
No, so it's not going to be an observation. So let's look at the next step would be question. So when you're wondering something, is that usually a question? It's kind of a tricky one.
No.
Okay, so if we skip question, let's go to hypothesis. So hypothesis is your educated guess. Is wondering a guess?
No.
No, it's not. Okay, so all we have left next is experiments and theory, and it's not going to be either of those. So what it actually is a question. That's what part of the scientific method it is. So the reason it's a question is because when you're wondering something, what you're doing is you are asking a question because you're saying, look at the next words, what type of fertilizer works best? That's a question, right? You're thinking, which one works best? So from there, you would go and make a hypothesis. Well, I think this one works best because of, and then do your experiments, so on and so forth. So this is a question. So number 2, a little bit easier, or maybe not easier, but hopefully more clear. A scientist predicting that mice will grow larger given vitamin C. So the key word here, predicting. So if you're predicting something, could that be observation, question, hypothesis, experiments?
Hypothesis.
Hypothesis, right. It's an educated guess. You're guessing. You're not sure yet. You're just saying, I think that they'll grow larger. Okay, number 3, it has all sorts of clues to it. This is knowing that mice will grow larger given vitamin C due to supporting evidence and experiments. So all sorts of things. Knowing, the fact that there's supporting evidence and experiments to back it up. So now it's not a hypothesis because that's an educated guess, but it's when your hypothesis turns into
A theory.
a theory. Yes, you now have the evidence to support it. You know this to be true. Right, the last one, feeling the texture of the soil in a predominantly dry climate. So keyword, feeling. If you're feeling something, you're touching it. It's one of your senses. So it's going to be
Observation.
observation. Right, that's what's starting the whole scientific method. You're feeling the texture of the dry soil. And the next step would be your question. Why is it grainy? Maybe might be your question. And then you'd go through all the steps from there. All right. So let's look next at the standard SI units for mass, length, time, and volume. So this was presented in the PowerPoints when we talked about the Treaty of the Meter and how all scientific fields agreed upon the metric system, the SI system, to collect their data in so that it was easier for us to communicate our results to each other. So you'd want to look up those 4 fundamental quantities and their units that were decided upon and enter those there. Okay, a hint, mass is kilograms. But I'll let you look up length, time, and volume on your own. All right. So we're going to skip 2 significant figures. So I'm trying to focus on more the calculations and less definitions here. So that, I know those are usually where people have more trouble. So I'm going to just write all these down, and we're going to write next to it how many sig figs are present in each. So you're using your rules for counting sig figs. We'll practice with that. So I know there's 36 questions, but some of them are as simple as this, where I'll give you a number and say, how many sig figs? And your multiple choice will be 1, 2, 3, 4, and then you'll just click the correct one. So, they're not all going to be difficult long conversions. It's a mix. So let's look at these guys. So the key with significant figures, if it's not a 0, yes, it counts. The trick is, when do zeros count? 2 instances. 1, if the 0 is between 2 non-zero numbers. The second instance is if there's a decimal and you've already started counting. Okay, so let's apply those rules and count the sig figs. So I'm going to use a different color here. So in A, we have 20.0. So we said if it's not a 0, it counts. So I'm going to go ahead and underline the 2 because we know that counts. Question is, do the zeros count in this case?
Yes.
Yes, why?
Because we started counting after this.
Right, because there's a decimal and we started counting, so you need to fit both of those for them to count. So there's a total of 3 sig figs for this one. Okay, so ones like this then tend to trick people because they see a decimal and they go, oh, those zeros count. Decimals or zeros count when there's a decimal, but you have to hit your first non-zero number first. So what that means is I can't start counting until I get to the 9. So the zeros before the 9, decimal or no, are not going to count. So these 2 9s count. If there were zeros after those 9s, they would count because I started counting. Since there isn't, it's just those 2. So only 2 sig figs in this one. How about the next one? 5,000. How many?
1.
Just 1? So we're saying the zeros don't count?
Right.
Why not?
Because there's no decimal or the ninth between the 2 numbers.
Right, there's no decimal, they're not between 2 non-zero digits, there's a comma and that's it. And commas, they don't make zeros count. So it's just 1. I could have 10 more zeros after this and it would still just be 1 significant figure. Okay, let's look at D. So we have 0.000417. So where do we start counting at what number?
The 4.
Not until we get to the 4. Okay, because we have to wait until we get to our first non-zero to start. So the 1 and the 7 count. Does this last 0 count?
Yes.
Yes. Decimal point, and we started counting. Good, so we have a total of 4. Almost said 2. 4 significant figures on that one. Last but not least, so we have 800, but notice there's a decimal point. Okay, so what this decimal point is saying, the person included it there specifically to say those zeros matter, don't forget about them. So the 8 counts and the zeros count on that one. All right, good. So it's important to be able to just, given a number, be able to count, but you also need to be able to do calculations with numbers and then report your answer to the correct significant figures. So that's what we're going to do next. And the rules are different for addition and subtraction than they are for multiplication and division. So you need to pay attention to what order of operation you're applying. So, first one is addition and subtraction together. Okay, so since it's addition and subtraction, we're going to use the rules for addition and subtraction, which are decimal places only. So most of our conversions are actually multiplication and division. So we get so used to counting sig figs as a whole and then picking the smallest one that when we get back to addition and subtraction, I wrote this down wrong on the board. This is a subtraction sign, sorry. When we get to addition and subtraction, we want to count sig figs as a whole. We need to remember the rules are different. And we're counting only decimal places and then picking the smallest one. Okay, so here. Since it's addition and subtraction, we're going to look at each number that we're using in the calculation and we are going to count decimal places only. So I'm starting at the decimal and seeing how many spots after the decimal. So my first number is going to have 2. What about my second? How many do I have after the decimal here? 3, right? Remember, it's decimal places. This 0, it doesn't count as a significant figure, but we're not counting sig figs. We're counting decimal places, so it counts. It's a placeholder. It's the 10th spot. So for that reason, this last one has a total of 6. Those zeros, even though they're not significant figures, they do count as decimal places. So we want to pick our smallest. So out of those, be the 2. Did anyone calculate this?
Yes.
What did you get?
2.69.
2.69. So you went up 2 decimal places already. You even rounded it for me. Okay. So when you report your answer, you're going to get a longer number than this. but you want to make sure when you report your answer that it only goes out 2 decimal places, just like we said here. Okay, so let's look, it's 2 decimal places, but how many total significant figures do we have? So 3 total. All of them are not 0, so all of them count as significant figures. So notice the difference. Decimal places is different than significant figures. So pay close attention to what the question is asking. Is it asking decimal places or is it asking significant figures? Multiple choice tests, it's mainly, most mistakes are made when you're not paying close attention to exactly what the question's asking. So reread the question. You have plenty of time. You have an hour and a half. Usually the exams, when we take them in person, you have an hour and 15 minutes. So I'm giving a little bit of extra time, and it's the same length that I usually give. So take your time. All right. I can do this one down here, I suppose. So number 3 there is saying, is a rounding problem. So we're rounding 185 to 2 significant figures. So we've done this before in class. This is the hard ones to round. Whenever you're rounding, you always count significant figures. You start from the left and go to the right. So since we want just 2, it's going to be the first 2 that we see. Okay, with rounding, you always look at the number next to it to see if it needs to remain an 8, or if it's 5 or higher, it would round up to a 9. So in this case, it is going to round up to a 9. The trick with these ones is you don't want to just stop at 19. So this is correct to the point that yes, there's 2 sig figs. It's correct to the point that yes, we rounded up to a 9, but it's not completely correct because I went from 100 and something down to 19. So this 5, we're going to change that and put a 0 as a placeholder. Because the 0 is not a significant figure, but it keeps me at the right magnitude. It keeps me in the hundreds. So 190 would be the correct way to round that. All right. So moving to number 4. So here we're dividing. So we're going to use the rules for multiplication and division, and those are sig figs as a whole. We are still picking the smallest. So what that means is when I divide this, I'm going to count the significant figures total in each number used in the problem, and I'll pick the smallest. That's what my answer will be reported in. So counting the top number, I have 4. The bottom, I don't start counting until the 6. The 0 after counts for 2. So once I divide this, I want 2 significant figures in my answer. No idea what that would be.
35.8 and then a lot of 3.
Okay. So on your calculator spits out that it's 3 repeating. But we just said 2 sig figs. So start counting left to right. First 2 count. Look at the number next to it. So it's going to round up to a 6. So that would be the correct answer with the correct number of significant figures. All right. So that takes care of significant figures, calculations with sig figs, scientific method portion. So now we're going to look at scientific notation. So I only have 2 examples here because I know a lot of calculators just put your answers into scientific notation for you. So there's not going to be a lot of these on the exam. But for those of you who don't have those calculators, I do want you to know how to do it. So just a quick review on that. So 61. When you're approaching a number in normal notation, to get it into scientific, the rules are that you want one non-zero number to the left of the decimal. So what you need to figure out is where do you want your new decimal to be. So if you want one non-zero number to the left, it's going to go between the 5 and the 6. Okay, that's going to keep you at 5.621. Now, to figure out the exponent, it's how many times you move the original decimal to get it to where the new one's at. So 1, 2, 3 times I have to move it. Now, to figure out if that's a positive exponent or negative exponent, there's 2 ways to remember it. One is, okay, well, I moved to the right, so it's negative, or the original number was less than 1, so it's negative. Just to show an example on the other side, let's do a large number, so a number greater than 1. You still follow the same rules. You're going to want your decimal so that there's one non-zero number to the left. The exponent is how many times you move the decimal to get it to where the new one's at. Notice I started at the end of the number since there was no decimal. I had to move it 7 times, and that's going to stay a positive 7 because the original number was huge. It was 84 million. So it was much greater than 1. Also notice, I didn't keep the zeros because you have to still take into account significant figures. And the zeros did not matter because there was no decimal in my original number. So I didn't bring them over in the scientific notation form. This one is a practice with significant figures, doing calculation, and scientific notation. So I'm multiplying. So I'm looking at significant figures as a whole. So I'm going to count the sig figs present in each number that I'm multiplying. So I have 4 there and 3 in the second number. So that means 3 smaller than 4, so I want 3 in my answer. And when I calculate this out, if I have a calculator that gives it to me in normal notation, I need to put it in scientific notation. Isn't it like 6 zeros and then 6, 7, 3? I remember that correctly. I did this problem yesterday in my other section. I didn't write down the answer, of course, so I always have to calculate it yet again. But yes, that's correct. So, if your calculator gives it to you like this, the question itself is asking for it in scientific. So that's another thing. Pay attention to what the question's asking. Does it want it in normal or does it want it in scientific? Okay, because it'll probably give you several options of both, and you want to make sure you read appropriately so you're picking the right one. So in this case, would be 10 to the, we want our decimal here between the 6 and the 7. 1, 2, 3, 4, 5, 6, 7. So 7 times, and negative because the original number was less than 1, and we moved to the right. So this takes care of basically that first homework assignment that we did, that first homework quiz. Right. So what we're going to look at next is what you hopefully did yesterday on the homework quiz, conversions, and then we'll move on to density and percent error. So conversions is usually the trickiest. It's usually the most time-consuming problems that you'll see on the exam. So what I have in the review, and I put it in a word problem form because I know on the board I usually just do, okay, go from here to here. So I wanted you to see a word problem because much like your homework, a lot of times it is in word problems and not just convert this to this. So number 1 is saying a ball has a mass of 22.305 grams. Make the following conversions and report. So what it's saying is, this is your given. This is the amount in units that you're going to be converting. So notice we're going to convert it to kilograms. We're also going to convert it, if you flip the page over, to milligrams and pounds. So we're taking the same number and we're basically converting it 3 times. Okay? So I'm just going to do step by step. So the first one is to kilograms. And notice at the top, right underneath the title conversions, it tells you some guidelines to help you figure out the conversions. So for metric to metric, you're supposed to use KHD DCM, that King Henry died drinking chocolate milk. If it's English to metric, you're going to use the conversion factor table, find a conversion factor, do your railroad tracks, that plus sign thing, okay? So what's important is to know what you're looking at. What type are you doing? So for metric to metric, there's usually a letter in common, or there's always a letter in common in your units. So that's how you can identify that if you're not familiar with that system already. English to metric, you probably won't see any letters in common between the units. So what type is this?
Metric to metric.
Metric to metric, we have the G's in common. So that means we can use this system. Because this system is only for metric to metric. We can't use it otherwise. And this system's nice because all we have to do is move the decimal. We don't have to divide, multiply, set everything up, cancel out what we don't want, all that stuff. So notice we have an empty space. What's going to go in that empty space? The letter in common. Okay, so I have a G in common. We're talking about mass. So G is going to go in that empty space. To figure out how many times I'm moving the decimal point, I look at where I'm starting, grams, and where I want to go, the kilo. So what that means, when I go over here, I want to start at the G and I want to go to the K. I have to move the decimal 1, 2, 3 times to the left to get from the G to the K. I'm going to do that same thing starting at the decimal point in the number. I said 3 times to the left, so 1, 2, 3. What's going to go in that empty space? A 0, correct. So it's going to be 0.022305 kilograms. Notice, I kept all the digits. Okay, I didn't round because I got sick of writing. There are 5 significant figures here, so I needed to keep all 5. So if you flip the page, they're asking you to take that ball with a mass of 22.305 grams and now convert it to milligrams. Okay, so we can use the same scale. And I know this, once again, because of the letter in common. It's still metric to metric, so I can still use the same scale. We're still talking about mass in grams, so the G can stay as well in the center there. The thing that's different are the prefixes, the where I'm going part, okay? So here I'm still starting at grams like in the last one, but this time I'm going to milligrams, the little m on the right side. I'm starting at the G, going to the m, so I get 1, 2, 3 times, but this time I'm going to the right. So the number is going to get bigger. Start at the decimal and go 1, 2, 3. So my new decimal now is on the right side of the 5. So that's going to give me 22,305 milligrams. Now, the last one in that series is asking me to go to pounds. Mass in pounds. So what that means is we're going from grams to pounds. This time, can we use the KHD DCM? No, this isn't metric to metric anymore. We can't just move the decimal. We have to look up in our conversions tables a conversion factor. So this is why you'll want those available. If you want, you can search the internet for a conversion factor and hope that they give you a reliable source. Okay? Most of the time they do, and it'll still work or get close enough that you can pick the right choice. But the conversion table should have everything you need. So if I look at my conversion tables, what I'll find is a conversion factor 453.6 grams is equal to 1 pound. That's right. So I'm talking about this big long conversion factors chart, and I'd look in the mass area. 453.6 grams, 1 pound. Yes. Okay. So you have to find a conversion factor. Once you find it, you start that plus sign, the railroad tracks. What you're going to put in this upper left-hand corner is the original number, the number you're trying to convert. You're going to take the conversion factor and place it so that you're getting rid of the grams and you're keeping the pounds. So where do I want the gram portion, that 453? Do I want it in the numerator or in the denominator?
In the denominator.
Denominator, down below. Because I need the grams to be on opposite sides of this horizontal line so that they cancel out, because I don't want them anymore. What I want is the pounds. So the 1 pound portion of this conversion factor goes up top. So that gives me 22.305 times, oops, that's a point. No, it wasn't clear at first. Times 1, which anything times 1 is just itself, so just skip that part. Divided by 453.6. So, once you do that division, you're going to get a long number. You want to figure your sig figs, so look at your original. Just like the other 2 problems, there should be 5 sig figs in your answer. Can you calculate that, or do you have an answer for me?
Yes. Well, it's 0.04917.
49?
Yes.
04917?
Yes.
Is there going to be any digits after that?
Yes. It's 32804.
Okay. The reason I asked for more digits, because if we stopped at the 7, we need 5, right?
Okay.
So 1, 2, 3, 4, so we need 1 more. So we'd stop at the 3 in this case, because remember that 0 doesn't count, because we can't start counting till the 4th. My units, where am I now? Pounds. So when you look at it that way, it doesn't weigh a lot. It's a very small amount, actually. All right. Do you guys have questions on conversions? Feeling comfortable with them? Okay, so what I'm going to do, just in the interest of time, and I can go back and do them at the end of class, I'm going to skip 2, which is more conversions, except for this time it's with length instead of mass. But you're going to approach them the same way. If they're metric to metric, you'll use KISS or dummy blink, don't chase me. If they're metric to English, you'll look up a conversion factor on your sheet, write it down, do the railroad tracks. So I'm going to skip that one just to make sure that we get a chance to look at a density problem and a % error problem, because both of those are going to be on your exam. So at the back page now, and under the density heading, looking at number 1. Okay, so I'm not going to write down the word problem itself. Instead, I'm going to go through the word problem and just write down the pertinent information. So the mass, the volume, the density. So it's a density problem, so we're using this equation. Density is equal to mass divided by volume. If we need to rearrange the equation, we talked about this density triangle. where we basically just take this equation and put it in there. So dmv, d, m on top, v on the bottom here. So this will help us. Vertical lines are multiplication, just like when we do the railroad tracks. Horizontal lines are going to be division lines. All right, so let's look at the first problem now and see what information they gave us and what they want us to solve for. So it says the density of acetone is 0.791 grams per milliliter. Okay, so that's the density, that's my D. 0.791 grams per mil. Notice I include the units when I write down the information, because I'm going to need to check the units and make sure they're matching with each other, make sure I don't need to convert. This is going to be really useful in forthcoming chapters. We're going to be doing a lot of converting in order to use equations. So next it says calculate the mass. So it says calculate the mass. That means my mass is my question mark. My mass is what they're asking me to solve for. So that means they're not giving me a value for mass in here because that's what I'm going to be solving. Instead it says calculate the mass of 5.4 liters. So that 5.4 liters, that's a volume. I know that because of the units itself. So that's why it's useful going all the way to the back to the first page of the review where it says what are the standard units for mass, length, time, and volume. If you know these, you'll be able to pick out the information and know what it represents in the word problems. So liters is a volume. So that's going to be my V value. So what I'm going to do next is come up with the equation. Notice I'm going to have to rearrange this equation, right? Because I'm solving for mass this time. So to rearrange that equation, I can use the density triangle. And to use this, you cover up what you're solving for. So I'm covering up the M, and that tells me to take the density and multiply it by the volume. So my equation is going to be mass is equal to density times volume. Before I get all excited and plug those in, I'm going to check my units. So my density is grams per mil. Okay, my volume, however, is in liters. So notice the discrepancy here. Density milliliters for the volume portion, volume liters. They don't match. I need them to match. So I am going to have to convert. So my first step is going to be to convert my 5.4 liters, and I'm going to want it in milliliters because I need these units to match. So to convert it, I need to know what type it is. So is it metric to metric or English to metric?
Metric to metric.
Metric to metric. LL has got a letter in common. That's nice because then all I'll need to do is move a decimal. So what's going to go in my empty space this time on the chart?
Liter.
Liters, the letter in common. L, we're talking about volume. Okay, so I'm starting at the L, that's what my units were originally in. What I want to get them in is milliliters, the M. So I'm going to go 1, 2, 3 to the right. Let me rewrite this to give you some space. Start at the decimal point and move 1, 2, 3 to the right. So I'm going to put zeros in those empty spaces. This is going to give me 5,400 milliliters. So when I go to solve, I want to use the milliliter version of volume, not the liter version. So now I have the correct units, and I can plug these two numbers in to that equation. So my mass is going to be density of 0.791 multiplied by the volume in milliliters. Let me put the units here so we can see better why we need it that way. So this is the reason we needed it in milliliters, so that they canceled out. Because now my units are grams, which is what mass should be measured in. Okay, that's the correct units for mass. So multiplying that out, before we look at our answer, let's go back to sig figs. So I have a feeling it's going to be a big number. Density, 3 sig figs. How many significant figures in volume? Just looking at the original number.
2.
Just the 2. So our answer should have just 2 significant figures in it. Yeah. 4271. Anybody get something different? Let me know. All right, so we said 2 sig figs, so just the 4 and the 2. Look at the number next to it. Is that going to stay a 2 or move up?
It's gonna move up.
It's going to move up. Okay, now we want to make sure, once again, to have placeholders here. We don't want to just write 43, because this is 4,000. So to stay in the 4,000 range, we're going to add 2 zeros so that we still have 2 sig figs. We're still in the 4,000 range. And I'm going to make sure to put my units before I circle it. Don't forget units as well. So that 5.4 liter sample consisted of 4,300 grams. All right, so this would be the hardest type of density problem you'd see because you'd have to convert before solving. Okay, there's more than one density problem on the exam, and you don't have to convert for every one of them. It'll probably just be one. So let's look at the second density problem. So you can see what a different type would look like. So for this second one, we're going to calculate volume this time. So whenever it says calculate and then gives you a variable, you can write that variable down, in this case volume V, and put a question mark by it. So it's saying calculate the volume in milliliters of 10.0 grams of a saline solution. So that 10.0 grams, you need to look. Well, we know it's not volume because that's what they're asking us to solve for. Density is grams per mil, so it's not that, so it must be mass. So mass is measured in grams, so that's how you would identify that as being your M value. Then it gives you a density, and it specifically tells you this is the density, 1.05. If it didn't specifically tell you that, you could look to the units, grams per mil, to figure that out. So this time we're solving for volume. So if you're using that triangle to rearrange, you cover up the B. So we're going to be taking mass and dividing it by the density. Okay, before I plug it in, check your units. So let's see, grams, grams, we're good. Okay, they're the same units. We don't need to convert anything. Much more straightforward because now we just plug in. We're going to put our 10 grams on top, our 1.05 grams per mil on bottom. Notice the grams are going to cancel, and our answer will be in milliliters. So when I divide that out, .5238, et cetera, 5238. Oops. But check your sig figs. So you go to the original numbers given to you in the problem, count your sig figs. So density is 3. How many in the mass?
3.
3, the zeros count. So they're both the same. So you need 3 total. The 9, the 5, and the 2. Look to the number next to it. Does that stay a 2 or round up to a 3?
Stays at 2.
Stays a 2 this time. Units are going to be milliliters because it's a volume. So that 10 gram sample, would measure out to be 9.52 milliliters in a graduated cylinder. Questions on density. We're going to start, or do, I should say, the percent error calculation then, because that's the last type of calculation you'll see. And that way I think we've covered all the types you'll see, at least. All right. So percent error. You'll want this equation handy during exam time. So have your notes out or wherever you happen to have written it. Or if you have your review sheet out, it's on your. So percent error. By the way, lab 2, you're going to be calculating percent error like 10 times. So you're going to need to know how to do this in lab for sure. So it's good that you've learned it already. That should just make that lab that much easier. All right. So here is the equation, and you'll see several different types of this equation, and by that I mean different words here, but it's all the same thing, okay? When we use this equation, we have the bars, absolute value. You are never going to get a negative percent. If one of you selects the negative one, because I will put it on as a choice, just don't, okay? You'll never get a negative. Just change it to a positive. The numbers don't change, just change the sign, all right? So measured, that's going to be the experimental value, the value that the student did. The estimated will be the measured. The true value, that's the value you're going to get from the table. That's the proven experimental data proof one, okay? So using that knowledge, you need to pick out, given the word problem, which of the values given to you are the measured and which one is the true. So for this one, it says a contractor estimated the weight of a boulder to be 42 pounds. The actual weight of the boulder was 37.8. So notice you're given two numbers. One of them's your measured, one is your true. So which one is the measured?
42.
42, because the measured, remember I said that's the experimental, that's the one, that's the guess one. And in this case, the contractor estimated. So estimated, that's what he's guessing it to be. So my measured is 42. And then later it says the actual weight. So actual being the true is 37.8. So now all you need to do is plug in those values and solve. When you do this, put the measured first, and it doesn't matter which one's first actually because it's absolute value, so no matter what, you'll get a positive number when you do that subtraction. Put the true value, 37.8 on the bottom. So this is the true. Key is to do the subtraction first and then divide. Okay, so you need to put this top portion in parentheses in your calculator. Otherwise, it's going to do the division first by orders of operation, and you'll get the wrong answer. So that's the most common mistake I see on this one. So 37.8 divided by 36.8. And then also, don't forget to multiply by that 100. If you forget to do that, it's not a percent. Okay, so I got 11%. Yeah, so it'd be 266. So I got 11%. And we get something different. You get 11? Okay. So 11% error. That means he was 11% off of what the true value was. His guess was 11% incorrect, to put it another way. Any questions? Okay. So I'm going to leave number 2 for you to work on your own. I'm going to put an answer key up. but I want to leave it blank so that everyone has the opportunity to do it before looking at the key, so that they can see if they are indeed comfortable with conversions, because that tends to be the most difficult part of this exam, is the conversion section. So